Program Development Cycle. Welcome, everyone. In this video, we will unravel the complexities of the program development cycle. In the realm of software engineering, the program development cycle stands as a cornerstone process, ensuring the seamless creation, deployment, and upkeep of software applications. Throughout our time together, we'll embark on a journey through the various phases of this cycle, shedding light on their significance and elucidating how they collectively pave the path to success in software projects. By the conclusion of this session, you'll emerge with a crystal-clear comprehension of the inner workings of the program development cycle and grasp why adherence to its meticulous structure is paramount for software development teams. Without further ado, let's plunge into the depths of the program development cycle and dissect each phase with precision and insight. Let's delve deeper into the essence of the program development cycle. In the realm of software engineering, the program development cycle embodies a systematic journey meticulously followed by development teams. Its purpose? To sculpt, refine, and deliver software applications with finesse. This cycle isn't merely a series of steps, it's a structured framework, a compass guiding teams through the tumultuous seas of software development. From inception to deployment and beyond, it provides a clear roadmap, ensuring no stone is left unturned in the pursuit of excellence. Each phase within this cycle is imbued with specific tasks and objectives, harmoniously working together like cogs in a well-oiled machine, all with a singular aim, the triumphant success of the project. Understanding the program development cycle isn't just advantageous, it's imperative. For software developers, project managers, and stakeholders alike, it serves as a beacon, illuminating the path to effective execution and management of software projects. The journey begins with the analysis phase, where the foundation of the project is laid. It's a phase of discovery, where requirements are gathered, and stakeholder needs are comprehensively understood. Activities encompass conducting interviews, soliciting user feedback, and scrutinizing existing systems, if any, to glean insights. The primary objective? To delineate the project's scope, define clear objectives, and establish requirements that the software must fulfill. Transitioning seamlessly into the design phase, architects and designers step into the limelight. Here, they craft a meticulous blueprint for the software solution based on the insights gathered during analysis. This phase sees the birth of system architecture, user interfaces, database structures, and other technical components. Design documents like system diagrams, wireframes, and data models serve as guiding lights, directing the development process with precision. Now, it's time to breathe life into the blueprint. The implementation phase, fondly known as the coding phase, witnesses developers weaving magic with lines of code. Armed with programming languages, frameworks, and tools, they transform designs into functional software components. Code undergoes rigorous with reviews and tests ensuring adherence to coding standards and requirements. As the software takes shape, it faces the litmus test of the testing phase. Here, functionality, performance, and reliability are scrutinized with eagle eyes. A plethora of testing techniques, from unit tests to tests, are deployed to unearth defects and ensure adherence to quality benchmarks. Test cases are executed diligently, with defects reported, tracked, and resolved to forge a product of stability and resilience. With the software deemed fit for the world, it's time for the deployment phase. Here, it spreads wings, ready to soar into the hands of end users or production environments. Installation packages are meticulously crafted, and the software undergoes installation, configuration, and testing in its designated habitat. Collaboration with system administrators, deployment engineers, and stakeholders ensures a seamless route, devoid of hiccups. Finally, the journey finds its resting place in the maintenance phase. Here, the software receives the care and attention it deserves post-deployment. Bug fixing, performance optimization, and feature enhancements become the order of the day, driven by user feedback and evolving requirements. Regular updates and patches are released, breathing new life into the software, enhancing its functionality and performance over time. The crucial starting point of the program development cycle, the analysis phase. Here, our focus narrows to understanding the very heartbeat of the software project, its requirements and objectives. Key activities within this phase form the bedrock of our journey. Gathering requirements. We embark on a voyage of discovery, seeking insights from stakeholders ranging from end users to clients, ensuring no perspective is left unexplored. Conducting engagements. Through interviews, workshops, and surveys, we peel back the layers, unraveling the intricate tapestry of requirements, and clarifying any shadows of doubt. Analyzing existing systems. Like archaeologists sifting through relics, we delve into the depths of existing systems, processes, and documentation, uncovering gaps and opportunities for enhancement. Defining scope. With a steady hand, we delineate the project's boundaries, setting clear, achievable objectives that will serve as guiding stars in our journey ahead. The overarching goal of the analysis phase? To forge a rock-solid foundation for the software development process, rooted in a profound understanding of user needs, business aspirations, and technical realities. Deliverables from this phase form the scaffolding upon which our project stands. Requirements documentation. Detailed accounts of functional and non-functional requirements, serving as the blueprint for our endeavors. Artifacts for clarity. Use cases, user stories, and other artifacts, crystallizing requirements into tangible forms, ensuring clarity and alignment. Project charter. A testament to our aspirations, outlining the project's goals, objectives, and boundaries, guiding our ship through stormy seas. In essence, effective analysis is the cornerstone of success, laying the groundwork for seamless transitions into design, implementation, and testing phases. It's not merely a step, it's the compass guiding our voyage through the program development cycle, the design phase, where dreams take shape and visions become reality. Following the insightful journey of the analysis phase, we now embark on the creative endeavor of transforming requirements into a detailed blueprint for our software solution. Key activities within this phase form the canvas upon which our masterpiece is painted. Architectural designs. Like master builders, we craft blueprints that define the very essence of our software system, outlining its structure and components with precision and foresight. User interface, UI, and user experience, UX. With the user at the heart of our endeavors, we design interfaces that are not just functional but delightful, ensuring usability and accessibility for all. Data models and database schemas. Like architects sculpting the landscape, we develop models and schemas to organize and manage the lifeblood of our application, its data, ensuring efficiency and coherence. Interface and API definitions. Bridging the gaps between modules and components, we define interfaces and APIs, laying the groundwork for seamless communication and integration. The overarching goal of the design phase? To weave a tapestry of requirements into a comprehensive design that will serve as our guiding star through the development labyrinth. Deliverables from this phase form the blueprint upon which our software solution stands. Architectural diagrams. Visual representations such as system diagrams and component diagrams, illuminating the intricate structure and interactions of our system. UI/UX designs. From wireframes to mock-up prototypes, we craft visual masterpieces that depict the soul and essence of our application, guiding users through intuitive journeys. Data models and database designs. The backbone of our application, outlining the very fabric of our data, ensuring coherence and efficiency in its management. Effective design isn't just aesthetics, it's about functionality, scalability, maintainability, and performance. It serves as a roadmap for the implementation phase, guiding developers in translating our vision into reality, one line of code at a time. Now, the heart of the program development cycle, the implementation phase, where lines of code transform visions into reality. Known colloquially as the coding phase, this stage is where our designs take flight, guided by the meticulous plans laid in previous phases. Key activities within this phase form the very building blocks of our solution. Coding. With fingers poised over keyboards, we translate design specifications into tangible code, adhering faithfully to established coding standards and best practices. Algorithmic wizardry. Armed with logic and creativity, we implement algorithms, functions, features outlined in our requirements and design documents, infusing our software with life and functionality. Integration. Like craftsmen piecing together a mosaic, we integrate disparate modules and components, forging a cohesive and harmonious whole that embodies the essence of our vision. Quality assurance. Through rigorous code reviews and peer programming sessions, we uphold the mantle of quality and consistency, ensuring that every line of code reflects excellence and integrity. The primary goal of the implementation phase? To breathe life into our designs, crafting software components that not only meet but exceed the requirements and design specifications. Technologies and tools at our disposal during this phase are the very tools of our trade. Programming languages. Java, Python, JavaScript, and more, serving as our medium of expression. Integrated development environments, IDEs. Our sanctuaries of productivity, provide canvas for our code. Version control systems. Git, the guardian of our codebase, ensuring collaboration and version management. Build automation tools. Maven, Gradle, and their ilk, streamlining our development process with efficiency and precision. Deliverables from this are the tangible fruits of our labor. Source code files. The embodiment of our craftsmanship, containing the implementation of modules and components. Documentation. From inline comments to comprehensive developer guides, illuminating the functionality and usage of our code. Compilaries or executables. Ready and waiting for the next phase, testing and deployment. Effective implementation demands meticulous attention to detail, unwavering commitment to coding best practices, and seamless collaboration among team members. It's the crucible where ideas transform into innovation, and where dreams take flight. The testing phase, the crucible where software transforms from mere code into a resilient and dependable solution. Here, we subject our creation to the rigors of evaluation, ensuring it emerges more robust than ever before. Key activities within this phase form the bedrock of our quality assurance endeavor. Test and design. Like architects drafting blueprints, we meticulously plan and design test cases, aligning them with requirements and design specifications to ensure comprehensive coverage. Test execution. With precision and diligence, we execute test cases, probing every nook and cranny of our software to verify functionality, performance, and reliability. Defect identification and reporting. Armed with keen eyes, we identify and report defects or issues found during testing, ensuring transparency and accountability in our pursuit of quality. Various types of testing are employed to fortify our software. Unit testing. Testing individual units or components in isolation, ensuring their correctness and integrity. Integration testing. Testing interactions between different modules or subsystems, verifying their seamless integration. System testing. Evaluate the system as a whole, validating its behavior and functionality in its entirety. Acceptance testing. Putting our software to the ultimate test with end users, ensuring it aligns with their needs and expectations. The primary goal of the testing phase? To unearth defects and ensure our software meets the lofty standards of quality before it ventures into the realm of production. Technologies and tools serve as our stalwart allies during this phase. Testing frameworks. JUnit, Selenium, and their kin, providing the framework for our testing endeavors. Bug tracking systems. Bugzilla, and others, serving as the repository of our software's imperfections, guiding us towards resolution. Continuous integration, CI, tools. Jenkins, Travis CI, and more, automating our testing processes with efficiency and efficacy. Deliverables from this phase serve beacons of insight and accountability. Test plans. Outlining our testing strategy, objectives, and schedule, providing a roadmap for our testing journey. Test cases and scripts, the ammunition of our testing arsenal, guiding us in our quest for quality and resilience. Test reports. Summarizing the results of our testing endeavors, providing a snapshot of our software's readiness for deployment. Effective testing isn't just about finding defects, it's about ensuring our software meets the highest standards of quality and reliability. It's the shield that guards against the specter of failure, ensuring our software stands tall in the face of adversity. Welcome to the crescendo of our journey, the deployment phase, where dreams transition into reality as software ventures into the hands of eager end users. Here, we navigate the delicate balance between precision and expediency, ensuring a seamless transition from development to production. Key activities within this phase form the backbone of our deployment endeavor. Packaging. With meticulous care, we encapsulate our software into installation packages or deployment artifacts, readying it for distribution to its destined habitat. Configuration. Like architects fine-tuning their masterpiece, we configure the target environment, ensuring compatibility and optimal performance for our software's debut. Deployment. With a flourish, we usher our creation onto the stage of production servers or cloud platforms, executing our deployment plan with precision and poise. Validation. With bated breath, we conduct smoke tests and validation checks, ensuring our software functions fully in its new environment, ready to dazzle end users. The primary goal of the deployment phase? To unfurl the banner of our software's availability, making it accessible to end users and customers alike. Technologies and tools become our allies in this endeavor. Deployment automation tools, Ansible, Puppet, Elk, streamlining our deployment processes with efficiency and consistency. Containerization platforms, Docker, Kubernetes, and others, providing agility and scalability in our deployment strategies. Cloud services, AWS, Azure, and beyond, offering the infrastructure and resources for our software's grand debut. Deliverables from this phase serve as guideposts for users and stakeholders alike. Installation guides, providing step-by-step instructions to assist users in installing and configuring our software, ensuring a smooth onboarding experience. Release notes, highlighting the changes and new features introduced in software release, offering insights into the evolution of our creation. Monitoring and logging configurations, setting the stage for ongoing performance tracking and analysis, ensuring our software operates at peak efficiency. Effective deployment isn't just about pushing code to production, it's about orchestrating a symphony of precision and finesse, ensuring a seamless rollout that delights end users and stakeholders alike. It's the final flourish in our journey, signaling the dawn of a new era for our software solution. The perpetual pulse of our software lifecycle, the maintenance phase, where our creation evolves and adapts to the ever-changing landscape of user needs and technological advancements. Here, our journey takes on a new dimension, as we shift our focus from creation to nurturing and refinement. Key activities within this phase form the bedrock ongoing support and enhancement endeavor. Performance monitoring. With vigilant eyes, we monitor the performance and usage of our software in the production environment, ensuring it operates at peak efficiency and availability. Defect identification and resolution. Like diligent caretakers, we identify and address defects, issues, vulnerabilities reported by users or discovered through proactive monitoring, ensuring our software remains resilient and dependable. Updates and enhancements. With a spirit of innovation, we make updates and enhancements to our software, enriching its functionality, performance, and security, and ensuring it remains at the cutting edge of technology. Technical support. With open arms, we provide technical support and troubleshooting assistance to users encountering problems with our software, ensuring a seamless user experience and fostering trust and satisfaction. The primary goal of the maintenance phase? To ensure the continued reliability, availability, usability of our software over its lifecycle, nurturing it like a tender sapling into a mighty oak. Technologies and tools become our steadfast companions in this ongoing journey. Issue tracking systems, Jira, GitHub Issues, and others, serving as our repository of reported issues and guiding us towards timely resolution. Version control systems, providing the framework for managing code changes, ensuring our software remains stable and reliable throughout its evolution. Automated monitoring and alerting tools, keeping a watchful eye on our software's health and performance, alerting us to potential issues before they escalate. Deliverables from this serve as testaments to our commitment to excellence. Patch releases, delivering bug fixes and security updates to address reported issues and vulnerabilities, ensuring our software remains resilient and secure. Version upgrades, introducing new features, improvements, and optimizations, keeping our software fresh and relevant in a rapidly evolving landscape. Documentation updates, reflecting changes and enhancements made to our software over time, ensuring users and stakeholders are kept informed and empowered. Effective maintenance isn't just about fixing bugs, it's about nurturing our software, ensuring it remains relevant and responsive to users and technological trends. It's the embodiment of our commitment to excellence, ensuring our software remains a beacon of reliability and innovation in an ever-changing world. Let's explore the dynamic rhythm that beats at the heart of the program development cycle, its inherent iterativeness. Here are some key points about the iterative nature of the cycle. Feedback loop: each phase of the cycle intertwines with the next, forming a continuous feedback loop that fosters improvement and refinement. Feedback from phase informs and enriches the subsequent phases, ensuring a continuous cycle of enhancement. Continuous evaluation: at every step of the journey, our software is subjected to evaluation, testing, and refinement based on feedback from stakeholders and users. This relentless pursuit of excellence ensures our software is responsive to evolving needs and expectations. Adaptation to change: the iterative approach grants us the flexibility and adaptability to respond to change with agility and resilience. Whether it's shifting requirements, emerging technologies, or fluctuating market conditions, we stand ready to embrace and adapt change, ensuring our software remains relevant and competitive. Variability in iterative cycles: iterative cycles may vary in length and intensity, depending on factors such as project complexity, timeline constraints, and stakeholder dynamics. Each iteration serves as a microcosm of improvement, contributing to the gradual evolution of our software solution. Agile methodologies such as Scrum and Kanban exemplify the iterative ethos, emphasizing collaborative development, adaptive planning, and incremental delivery. By embracing these practices, development teams can harness the power of iteration to deliver value incrementally and sustainably. By embracing the iterative nature of the cycle, development teams can navigate the complexities of software development with confidence and clarity. With each iteration, we refine our craft, address emerging challenges, and deliver value incrementally, paving the way for a more successful and sustainable outcome. Let's delve into the significance of adhering to the program development cycle, a cornerstone in the journey towards delivering exceptional software solutions. Here are several compelling reasons that underscore its importance. Ensures high-quality software. Through a structured and systematic approach, the cycle lays the groundwork for building software with stringent quality standards, fulfills user requirements, and operates reliably in the intended environment. Minimizes errors and bugs. Each phase of the cycle integrates activities like requirements gathering, design reviews, and testing, enabling early identification and rectification of errors and bugs, thus mitigating and enhancing product stability. Enhances user satisfaction, involving stakeholders throughout the development process and iteratively refining the software based on feedback ensures alignment with user needs and expectations, ultimately fostering higher levels of user satisfaction and loyalty. Facilitates collaboration and communication. The cycle fosters a culture of collaboration and open communication among team members, stakeholders, and end users, ensuring a shared understanding of project goals, requirements, and progress, thus fostering synergy and cohesion. Provides clear roadmap. By breaking down the development process into distinct phases, the cycle offers a clear roadmap for project planning, execution, and management, empowering teams to stay organized, focused, and aligned towards achieving project objectives. Supports agile practices, aligned with agile principles such as iterative development, continuous improvement, and customer collaboration. The cycle enables teams to respond swiftly and effectively to changing requirements and market dynamics, delivering value incrementally and adaptively. In summary, adhering to the program development cycle is paramount for ensuring timely, budget-conscious, and high-quality delivery of software projects. It serves as a framework that empowers development teams to navigate complexities, mitigate risks, and deliver successful outcomes that delight stakeholders and end users alike. Let's draw inspiration from real-world examples of companies and projects that have masterfully implemented the program development cycle, achieving remarkable success in delivering high-quality software solutions. Google's Software Development Lifecycle, SDLC. Google's rigorous SDLC process emphasizes iterative development, continuous iteration, and automated testing. This approach has enabled Google to produce robust and scalable software products like Gmail, Google Maps, and the Android operating system, which have revolutionized how we interact with technology. Microsoft's DevOps practices. Microsoft has embraced DevOps practices, including continuous iteration, continuous delivery, and automated testing, to streamline the development and deployment of its software products. By adopting these practices, Microsoft has achieved faster release cycles, improved collaboration among teams, and heightened customer satisfaction across products like Microsoft Office 365 and Azure. Agile methodologies in software startups. Countless software startups leverage agile methodologies such as Scrum and Kanban to rapidly develop and iterate on their products. By embodying agile principles like customer collaboration, adaptive planning, and incremental delivery, startups can swiftly respond to market feedback and pivot as needed to success. Examples include disruptive startups like Slack and Airbnb. Open source projects. Many open source projects adhere to the program development cycle to develop and maintain software collaboratively. Examples abound, including the Linux kernel development process, projects under the Apache Software Foundation's umbrella, and the ongoing development of popular programming languages and frameworks like Python, Ruby on Rails, and React. These projects demonstrate the power of community-driven development and iterative refinement. These examples highlight how structured and iterative development processes can yield remarkable outcomes across domains and industries. By studying and emulating the best practices from successful projects, development teams can elevate their own development cycles, fostering innovation and delivering impactful software solutions that resonate with users and stakeholders alike. As we navigate the program development cycle, we encounter a myriad of challenges that test our resilience and ingenuity. Let's explore some of these common hurdles. Changing requirements. The only constant in software development is change. Requirements may evolve due to shifting business needs, market dynamics, or stake feedback. Managing these changes while balancing project timelines and budgets requires adaptability and foresight. Communication issues. Effective communication is the lifeblood of any successful project. Miscommunication or lack thereof among team members, stakeholders, and end users can lead to misunderstandings, delays, and errors, hindering project progress and success. Technical complexity. Developing complex software solutions with intricate architectures, integrations, and dependencies presents technical challenges. Ensuring compatibility, scalability, and performance while managing technical debt demands expertise and careful planning. Resource constraints. Limited resources, be it time, budget, or skilled personnel, can constrain the development process. Balancing competing priorities and optimizing resource allocation is vital for achieving project objectives within constraints. Quality assurance. Ensure software quality and reliability through comprehensive testing and validation is paramount. However, challenges such as inadequate test coverage, limited testing environments, and time constraints can compromise the effectiveness of QA efforts, risking the stability of the final product. Project management. Effective project management is the linchpin that holds the development cycle together. Challenges like scope creep, schedule delays, and budget overruns necessitate proactive management and mitigation strategies to keep the project on track and within bounds. Addressing these challenges requires a holistic approach encompassing proactive planning, effective communication, collaboration, and adaptability. By recognizing and addressing potential challenges early in the development process, teams can mitigate risks and pave the way for successful project outcomes. Let's explore the arsenal of tools and technologies that support the program development cycle, empowering teams to collaborate, automate, and streamline their development efforts. Here are some key categories along with examples within each. Integrated Development Environments, IDEs. Examples: Visual Studio, IntelliJ IDEA, Eclipse. IDEs offer comprehensive development environments equipped with features like code editing, debugging, version control integration, and build automation, enhancing developer productivity and efficiency. Version Control Systems, VCS. Examples: Git, and Mercurial. VCS enables developers to track changes to source code, collaborate on projects, and manage code repositories efficiently, ensuring version control and facilitating seamless collaboration. Project management tools. Examples: Jira, Trello, Asana. Project management tools aid teams in planning, organizing, and tracking project tasks, milestones, and deadlines, fostering communication and collaboration among team members. Continuous integration/continuous deployment, CI/CD, tools. Examples: Jenkins, Travis CI, Oracle CI. CI/CD tools automate the build, test, and deployment processes, enabling teams to deliver software updates quickly and reliably, thereby improving development efficiency and product quality. Testing frameworks. Examples: JUnit, Selenium, PyTest. Testing frameworks provide libraries and tools for automating and executing various types of tests, including unit tests, integration tests, and UI tests, ensuring software quality and reliability. Containerization platforms. Examples: Docker, Kubernetes. Containerization platforms facilitate the packaging and deployment of applications in lightweight, portable containers, enhancing scalability, resource utilization, and deployment consistency across diverse environments. Collaboration tools. Examples: Slack, Microsoft Teams, Zoom. Collaboration tools facilitate communication, file sharing, and real-time collaboration among team members, promoting transparency and productivity in distributed or remote teams. Documentation tools. Examples: Confluence, Markdown, Sphinx. Documentation tools assist teams in creating, organizing, and sharing project documentation, including requirements, design documents, and user manuals, ensuring clarity and accessibility throughout the development lifecycle. By leveraging these tools and technologies effectively, development teams can streamline their processes, enhance collaboration, and accelerate the delivery of high software solutions, thereby maximizing their productivity and success. Embarking on the program development cycle journey necessitates adherence to best practices that underpin project success and attainment of desired outcomes. Here are some key best practices to uphold. Requirements management. Clearly define and document project requirements, ensuring they are measurable, achievable, and aligned with stakeholders' needs and expectations. Regularly review and validate requirements with stakeholders to ensure clarity, accuracy, and completeness. Design principles. Follow design principles such as modularity, encapsulation, and separation of concerns to craft robust, scalable, and maintainable software architectures. Document design decisions and rationale to foster understanding and collaboration among team members. Code quality. Adhere to coding standards and best practices to ensure consistency, readability, and maintainability of code. Conduct reviews and peer programming sessions to identify issues, share knowledge, and elevate code quality. Testing strategies. Implement a comprehensive testing strategy encompassing unit tests, integration tests, system tests, and acceptance tests. Automate testing processes wherever feasible to boost efficiency and reliability. Continuous integration/continuous deployment, CI/CD. Establish CI/CD pipelines to automate build, test, and deployment processes, facilitating swift and frequent delivery of software updates. Ensure that CI/CD pipeline are robust, scalable, and seamlessly integrated with version control systems and testing frameworks. Agile principles. Embrace agile principles like customer collaboration, iterative development, and responsiveness to change to swiftly adapt to evolving requirements and market dynamics. Cultivate a culture of transparency, accountability, and continual improvement within the development team. Documentation and communication. Maintain comprehensive and up-to-date documentation spanning requirements, design documents, technical specifications, and user manuals. Foster open and transparent communication among teams, stakeholders, and end users to ensure alignment and proactively address any concerns or issues. By integrating these best practices into the development process, teams can fortify collaboration, bolster productivity, and deliver software solutions of exceptional quality that not only meet stakeholder expectations but also drive tangible business value. Alright, let's dive into a fascinating case study that will bring the program development cycle to life. Development of a task management application. Analysis phase. Picture this: you're tasked with creating a task management application that'll revolutionize how teams organize their work. But where do you start? First up, you gather around, understanding what everyone wants from this app. You interview stakeholders, dive deep into their needs, and validate requirements through user feedback. Then, armed with insights, you map out the project scope and goals, laying the groundwork for the journey ahead. Design phase. Now comes the fun part, designing the blueprint of our app. We sketch out the architecture, meticulously crafting how the database will be structured, the user interface will look, and how everything will flow together. We whip up wireframes and mock-ups, bringing our ideas to life, and gather feedback from stakeholders to ensure we're on the right track. Technical specifications are documented, serving as our guiding light in the development maze. Implementation phase. Time to roll up our sleeves and start coding. Armed with languages like JavaScript, React, and Node.js, we breathe life into our designs. We're like wizards conjuring up spells, except our magic is writing lines of code. We integrate third-party tools and APIs, adding layers of functionality and finesse to our creation. Testing phase. But wait, before we unveil our masterpiece to the world, it's time for the ultimate test. We craft test cases, meticulously checking every nook and cranny of our app. Unit tests, integration tests, end-to-end tests, you name it, we've got it covered. Any bugs or issues we uncover, we squash them with the might of a giant's foot. Deployment phase. The moment of truth has arrived. With our application polished and primed, we package it up and send it off to its new home, the production servers or the cloud. We ensure everything is configured perfectly, crossing our fingers as we hit the deploy button. Post-deployment testing gives us peace of mind that everything is running smoothly. Maintenance phase. But our journey doesn't end here. We enter the maintenance phase, where we become the guardians of our creation. We listen to user feedback, tackle bug reports head-on, and sprinkle in new features to keep things fresh. It's a cycle of continuous improvement, ensuring our app evolves with the ever-changing landscape of user needs. This case encapsulates the essence of the program development cycle, a journey filled with creativity, challenges, and triumphs, culminating in the creation of a software solution that makes a real difference in the lives of its users. As we reach the culmination of our journey through the program development cycle, let's reflect on the key takeaways. The program development cycle serves as a cornerstone framework guiding software projects towards successful completion, ensuring they bring value to stakeholders. Throughout our exploration, we've delved into each phase: analysis, design, implementation, testing, deployment, and maintenance, uncovering their significance in the development process. We've emphasized the criticality of adhering to the cycle, embracing best practices, and harnessing tools and technologies to streamline development and deliver top-notch software solutions. By understanding and embracing the program development cycle, development teams gain the power to effectively manage requirements, design robust architectures, validate software, deploy seamlessly, and maintain products over their life cycles. Ultimately, following the program development cycle empowers teams to deliver projects punctually, budget, and with the desired quality and functionality, thus elevating customer satisfaction and fostering business success. Thank you for your unwavering attention throughout this journey.